All right. Good afternoon or good morning, as the case may be. Welcome back. You are here at day 5 of ASAP's Climate Service Providers Academy. And today we are going to be exploring climate data and information for the Caribbean, including Puerto Rico and the U.S. Virgin Islands. And as always, we will be here from 1 to 3 p.m. Eastern Time. And we're so glad that you are all joining us today. Here is our agenda for today. We are so pleased to be hosted today by the Caribbean Climate Adaptation Network. And we are going to first hear from Dr. Pablo Mendez Lazaro on building equitable and adaptive capacities of the U.S. Virgin Islands and Puerto Rico. Then we are going to be hearing from Dr. Mimi Scheller, Dr. Sarah Strauss, and Dr. Sarah Molinari on project-based learning methods for improving community climate adaptation. Then we'll have our break, and then we'll have 2 more incredible presenters, Dr. Eric Harmson on evaluating drought and water resources, and Dr. Patricia Chardin Maldonado, who will be presenting on the Caribbean Coastal Ocean Observing System. And here you can see our wonderful speakers who are going to be starting us out this afternoon. So first we'll hear from Dr. Pablo Mendez Lazaro. He works at the Department of Environmental Health of the University of Puerto Rico, Graduate School of Public Health. He's leading science on climate change, equitable climate adaptation, and public health. He's a geographer by training and expanded his transdisciplinary background by studying a master's in marine science, a PhD in environmental sciences, and 3 years of a postdoc on climate change and weather extreme events at University of South Florida College of Marine Science and the San Juan Bay Estuary Program in Puerto Rico. He is the chapter lead of the ongoing 5th National Climate Assessment, which hopefully we'll all get to see very, very soon. And he is the lead principal investigator for the CAPRISA program, Caribbean Climate Adaptation Network, or CCAN. We'll also hear in this segment before our break from Dr. Mimi Scheller, who's the inaugural dean of the Global School at Worcester Polytechnic Institute, Massachusetts. She was professor of sociology, head of the sociology department, and founding director of the Center for Mobilities Research and Policy at Drexel University. She has an AB in history and literature from Harvard University and an MA and PhD in sociology from the New School for Social Research. She researches Caribbean cultural history, has been doing that for more than 25 years and published extensively in mobilities research, Caribbean and Haitian studies, mobile media, public space, climate justice, and infrastructure. Dr. Sarah Strauss is a professor of anthropology and co-director of the graduate program in community climate adaptation at the Global School at Worcester Polytechnic Institute. Her research focuses on the intersection of environmental and health issues, values, and practices as they relate to climate adaptation and energy transitions. She's conducted ethnographic fieldwork in Rishikesh and Auroville, India, many other places, and she's currently working on a new book, The Yoga of Change, Tales of Energy, Climate, and Culture in the Anthropocene. And finally, in this segment before our break here, we will be hearing from Dr. Sarah Molinari. Dr. Sarah Molinari is a postdoctoral research associate at Florida International University. She holds a PhD in anthropology from the CUNY Graduate Center, and she works at the intersection of ethnography, critical disaster studies, feminist geography, and digital humanities. So with that, we are so pleased to invite up our first speaker, Dr. Pablo Mendez Lazaro, and really glad to have you all with us today.
Thank you, Rachel. And good morning or good afternoon. Sorry, it's a little bit cold here where I am. And good morning and happy to be here. Can you hear me well?
Yeah, you sound great.
Okay, perfect. I'm Pablo Mendez Lazaro. I'm going to be speaking a little bit on general of what is CCAN, the Caribbean Climate Adaptation Network, and part of the NOAA CAPRISA team. This is one of the newest programs in the NOAA CAP. We started recently in September 2022. So we are just starting our second year working in the Caribbean. I was trying to click to go to the next slide and I mute myself. Sorry for that. So if you have been participating in the multiple sessions that I've been providing for all of you, you are probably aware on the kind of vision that NOAA, formerly known by RISA, are using now. So it's now called Climate Adaptation Partnership, which is mainly proposing usable science to improve better decisions and to improve decision-making activities, to improve capacities in agencies, state agencies, federal agencies, municipalities, and also community-based organizations and organizations that are working on climate adaptation, sustainability, or related disciplines to produce novel climate solutions as well, instead of just developing early warning system or new climate projections and model, but also how can we start working with our communities and our practitioners and partners for new climate solutions, in this case for the region. Building long-lasting collaborations and partnership, which is something that is not trivial. Obviously, partnerships are like building a friendship, right? Or a marriage or a couple. There are basic principles of relationship that need to be respected. That is not necessarily related to the discipline. And then doing collaborative research. So basically, the reason why you will be seeing that the SICAN is one of the, and I think that I noticed that when I'm here in the annual meeting, that we are one of the biggest in terms of the number of institutions working together. Sorry, next slide. I did the same thing again and I mute myself. I'm trying to pass. We are almost 10 or 11 different institutions working together, covering from Massachusetts, some covering some areas in the east coast of the United States, going south until to South Florida with the University of South Florida, and into the west in the University of Texas. Then we're going down to the Caribbean region, where we have the University of Puerto Rico, which is the institution that is leading locally the activities of SICAN, in coordination also in partnership with the Virgin Islands. And in Puerto Rico, we have two different campuses, the University of Puerto Rico Medical Science Campus and University of Puerto Rico in Mayagüez, in collaboration as well with the Caribbean Coastal Observing System, which is part of NOAA as well. And we have one federal agency that Tisha Muñoz Erickson is working at the Forest Service at the International Institute of Tropical Forestry. That is one of the, it is the local region for the Forest Service in Puerto Rico, but it's also providing services to the Virgin Islands. Can you go to the next slide, please? So we are, this is a magnificent team, right? We are diverse in gender, diverse in culture, diverse in regions, diverse in disciplines. So this is a multidisciplinary team composed of the amount of people that you're seeing here. I'm not counting because it's increasing. The number is changing constantly. But I will say that this is the core team, right? Coming from the amount of institutions and the institutions that I already mentioned. And I'm not going to be talking about all of them. But as you can see, some of them are going to be speaking as well of the kind of work that they're doing in Puerto Rico and in Virgin Islands, in coordination also and collaboration with the network. Can we go to the next slide, please? Beside the core team that we have composed by researchers, scientists, and professors, we also have support of multiple other graduate students and students that are working with us, that are working with communities, that are being led and mentored by this magnificent team that I already mentioned. So we have graduate students in UPR, graduate students from most of the different institutions that are part of this network. And I always like to acknowledge the kind of work that they're doing, because without their support, so it's sometimes more difficult to accomplish the goals that we want. Can we go to the next slide, please? Thank you. So SICAN is based also in the principles of justice, diversity, equity, and inclusion. And I'm using this kind of graphic just not because I agree with it, but because it's a simple way on how to show when we're talking about inequalities, equities, justice, right? But if we go to the right side of the panel, where we're seeing the ladder that the girl is using, the questions that we would like to answer is, how do we build that ladder? What does it take to work and to design that kind of ladder to actually work on diversity and inclusion. And not only when we're talking about underrepresented and underserved communities, not only for frontline community, because in our case, at least in the Caribbean, we prefer to use the word underserved and underrepresented because it's not masking and it's more tied to the underlying causes on why most of these communities are being more vulnerable or sensitive to climate stressors, and are because most of them are related with all of the social determinants of health, inequalities, injustice, and access to resources, and multiple other factors that you will continue hearing during this presentation and the other colleagues as well. So these are basically the principles on what we're working. Can you go to the next slide? Thank you. So we are using human-centered design in order to work with what we want to do. And I will talk about the goal. We are designing a knowledge network aiming to work on climate adaptation with underserved communities in Puerto Rico and Virgin Islands. In order to do that, we are using the human-centered design. And the human-centered design, it means that you start working by the people most affected by the problem to be solved. Simplified, right? So it doesn't matter if it is an agency, a government agency, they do have their own problems. So working, deeply listening to the problem that they have and being able to work and to co-design solutions hand by hand, working with them, working with communities. So instead of us getting into a community, getting into an agency to say we are the experts, we are the professors, we are the scientists who have the solution and the magic sticks to solve all of your problems. We are using a different kind of approach. So we are going to the communities, and we're going to the municipal agencies and the state agencies, and we're listening to the problem. We're listening to the issues that they have. We're listening to the leaders, to the hospitals, and then working with them, we are co-designing potential solutions based on their problem that they are already identified. Can we go to the next slide? So that's the reason why we are proposing this knowledge action network, right? To build adaptive capacities for future climate extreme, plan responses for cascading climate hazards, and governance crises. So how can we, with our network, with the amount of knowledge, science, and information that we might have, can help and very better prepare for climate extremes at all different levels? Can we go to the next slide, please? Okay. Sorry for this slide, but basically when we're talking about the human-centered design, this is something that I've already explained. It means that it's composed of different phases. It's a planning process, and that is what we did during the first year. We dedicate a lot of time and effort in doing meetings, dialogues, and conversations with the different stakeholders, communities, practitioners, in order to better understand the context of climate adaptation in Puerto Rico. What is happening? What are the kind of programs? What are the kind of initiatives? What are the kind of problems? What are the resources available? What are the specific needs that are occurring, that are needed in the different layers all over the islands, but also in Virgin Islands? So learning from them, then we might be able to start working for the next couple of years on target issues, on target problems that are literally addressing real problems with the communities. Can we go to the next slide, please? In order to do that, we are islands, right? So we have that geographic isolation. We are based in the Caribbean region. So we are expanding our collaborations and partnership as well in the region, not only with Puerto Rico and the U.S. Virgin Islands, but also expanding to some other islands regionally. So what we noticed when we were writing this proposal is that in the case of Puerto Rico and Virgin Islands, we live with islands neighbors, but in most of the cases, we're paying more attention of what is happening in the continental U.S. than what is happening with our neighbors. Our neighbors share similar histories, similar economical problems, similar climate hazards, and they do have also proposing similar climate solutions and adaptation. They share also some issues with inequalities, injustice. So we might be able to learn from others on what they're doing from similar contexts, but we might be also able to transfer the amount of knowledge that we have in our network and the kind of things that we are doing in Puerto Rico. So we are expecting that we might be able to work together on regional solutions as well. So learning from one island to another. That's the macro level. At the meso level, we are thinking something similar between Puerto Rico and Virgin Islands, meaning that we are working at the state level in each of the different territories in Puerto Rico, but also in Virgin Islands. And also, how can we provide that space to transfer the knowledge between the two territories? And in this case, we're talking on mainly the meso level, is considering mainly the almost 4 million citizens that live in these both territories. In the case of Puerto Rico, we're talking about 3.1 or 3.2 million citizens, Hispanic population. And in the Virgin Islands, they are living in 3 different islands, and Thomas and Jonas and Croix, mainly Afro-Caribbean population, English speakers, and multiple other similarities, but multiple others differences. And at the micro level is where we're trying also to connect and to link the different scales, working not only with community-based organizations in the case of Puerto Rico and Virgin Islands, but also on top of that, in the case of Puerto Rico, we have another layer that is municipalities. So we have that opportunity to work also with another administrative layer that have direct contact and impact on communities and citizens. In the case of Virgin Islands, they don't have that administrative layer as in Puerto Rico. So we are not working with municipalities, but we are enhancing collaboration with other NGOs and community-based organizations with the help of our partners at the University of Virgin Islands. Greg Waddell Kim Waddell, sorry, and Greg Waddell. Can we go to the next slide? In terms of the hazard, and I'm going to be very quickly about it. So we're facing almost a lot of different climate hazards, from drought to extreme rainfall, floods, coastal floods, riverine floods, very powerful strong hurricanes. Now more recently, in the west coast of Puerto Rico, all of a sudden we have experienced 3 tornadoes. We don't know if that is going to be the pattern, if that is the norm, if that is part of the projection that we are going to be seeing more often. So that is a question that, at least for the National Weather Service, they're asking themselves, if this is something that we need to be prepared, if this is something that it's going to become more often and more frequent in Puerto Rico. So yeah, those kind of things. But I don't want to consume a lot of time talking about the climate hazard that we're facing. I think that these images can speak by themselves, and we can go to the other one. Because after all, this is not necessarily the most important thing for the Caribbean region, and when we're talking about climate adaptation. Can we go to the next slide? So all of these hazards have the potential, they are extreme weather events. So the extreme weather events, they can have the potential to interrupt the continuity of operations in society, right? So they're interacting with the institutional context, meaning how well prepared can be a country, an island, a municipality, a community. So that institutional context, do we have plans? Do we have programs? Do we have initiatives? Do we have the budget to realize or to build the kind of things that are needed to be better prepared? And I'm not talking building as an infrastructure. We can build social things as well. We can build social infrastructure to be better prepared. And in the other side, we have also the individual component and the social components, right? And these are the social determinants of health. So what are the characteristics and the profile of the population that is experiencing this kind of extreme weather? And we're talking that we are elderly populations, that we have pre-existing health conditions, that we're living below poverty level, that we have a lot of poverty, that we have a lot of unemployment, that we don't have access to resources, that we don't have access to power. That is also related to political issues and colonial historical issues as well, that are still part of the problem. In the case of Puerto Rico and Virgin Islands, as I mentioned, both of us have been citizens for more than 100 years, but we're territories. So we don't have the same rights, we don't have the same access to resources, and we don't have the same access to power as many other states or many other citizens in the United States. So the social determinants of health are the conditions on where a citizen, an individual, is born, is raised, it also works, and it dies. So it's interacting with all of the different factors and components that are shaping the way and how the people are living. Okay, so age, gender, hereditary factors, as you can see here. So those are the questions that we need to answer. what is the profile of the population and how this is being exacerbated by the climate stressor that we are seeing here. Can we go to the next slide? And this kind of information will help us also. So we don't need to only understand the climate projections and climate model. We know what will happen. We know what is happening. And we have a pretty good idea on how the climate will be changing and is changing in the Caribbean region. We don't have probably the granularity that we will need in some cases to work in detail with certain communities, but we have a pretty good understanding of what is happening. But what we don't know, and we're still asking ourselves, is about the social component, the social factors, and the profile of the communities, right? Who is going to be exposed to these climate hazards? Are there going to be people that are more likely to need health services because we might be continuing with pre-existing health conditions, cardiovascular disease, diabetes, obesity? Are we talking that we will have the capacity to improve our economic situation? We are in bankruptcy. We have a lot of unemployment. 48 or 49% of the island in Puerto Rico is living below the poverty level in one of the United States. Those are the kind of things, those are the kind of questions that we need to ask ourselves. Who is going to be experiencing these issues? Are we able to modify those factors to make them less vulnerable to climate extreme events? Do we have the capacities? What kind of things do we need to modify today in 2020 to help future generations to be better prepared for climate change, right? And we need to talk about those characteristics: social factors, social integrities, injustice, economy, inequality. Okay, can we go to the next slide? And I'm sure that my colleagues will give you more example about it on what they're doing as well. Oops, something happened here, but okay, with this slide, but I can explain it. So in this slide, this is where I can summarize in a certain way on where we are in terms of thinking with collaborations after 1 year of working in Puerto Rico, doing the dialogues, conversations, and meeting with communities and stakeholders, as I mentioned. So during the first year was like a planning phase, right? So we met with a couple of foundations and communities in order to understand what they were doing. So Foundation for Puerto Rico is a local foundation that is working with HUD and CDBG funds on recovery, and they are working with 79 different entities on community climate adaptations and resilience plans. So we are building partnership with them. We're supporting the kind of effort that they're doing with different community-based organizations all over the island in terms of building capacities, workshops, meetings, conversations, and multiple other things. In the right side of the panel, you are seeing a logo that is called the Alianza. The Alianza is a group of people and organizations composed by academia, scientists, federal agencies, and community-based organizations as well. That is mainly working on the issues of flood control program and flood mitigation programs in the city of San Juan, mainly in El Rio Piedras. El Rio Piedras is the main river that it crosses the city inside of San Juan, and it's going to be impacted by the Corps of Engineers. And the communities are concerned on how this kind of mega infrastructure might be impacting and affecting their quality of life, but also it's not going to be enough to solve the flood issues that we're facing in the San Juan metropolitan area. So there is this organization, this alliance of community scientists and stakeholders working together in trying to propose alternative, not only for getting infrastructures or these kind of new technologies and visions, but also on participatory processes. How can we also be incorporate in those decisions since the very first beginning, instead of what is happening, so that the Corps of Engineers is coming without one idea, and all of a sudden the community only have the opportunity to react to what they're seeing instead of they being part of the design for the Corps of Engineers. In the last panel below, the lower part of the screen, we're seeing a collaboration with the National Weather Service. So the National Weather Service is the agency responsible of the San Juan office, the agency responsible for provide weather information on a daily basis for Puerto Rico and Virgin Islands. They're doing it in both languages, in Spanish and English. So that's a huge responsibility. And they also have a mandate to work on climate ready nation. But the climate ready nation is mainly working on risk, right? Explaining the kind of risk that are affecting our nation. And in this case, the kind of risk, climate risk, that are affecting our territories and our communities. But in the case of SICAN, what we are helping is that explaining only the kind of risk that our communities are facing is one thing, but it's probably not enough. And it's not enough if we would like to move to climate adaptation. So in the case of SICAN, we're joining effort to say, okay, so how can we move forward and going beyond only explaining the climate risk that the communities are facing? How can we start working on all of the other kind of things that I already mentioned? In the right side, the lower panel, we are seeing the logo of Caricus and Ecoexploratorio, and you will listen from Caricus, right? So after the summer of 2023 in the Caribbean region, the Caribbean region is well known to be warm and humid all year long, right? But after the summer of 2023, we have been facing extreme heat events since more than 10 years already. And we have the evidence, the reason why the National Weather Service already developed, in collaboration with us, the first early warning system for heat, right? But it was, if in a certain degree, it was the people were not believing, or agencies were not agreeing on heat as a problem. But all of a sudden, the extreme heat that we faced during the summer of 2023, it makes them open their eyes. So it was impacted multiple sectors in Puerto Rico. The infrastructure, the energy system was unable to provide sufficient energy because of the energy demand that the people and the communities were using in order to mitigate the extreme heat episode that they were facing. The school, the teachers, they were complaining that they lack the correct infrastructure or protocols and policies to protect themselves on heat and to protect their students. So we received a call from the Department of Education to start working with them on adaptation for heat and to better understand how heat is also impacting the schools, and also how can we help in design and building protocols, a standard protocol for the school on how to react and how to be prepared as well for extreme heat in the school environments or learning environments. In the other side, we have also the Local 2030 Island Network Community of Practice, which is a network that it was created in 2019 under the United Nations General Assembly. So it's aiming to work on promoting collaboration and climate adaptation and sustainability in different island states, right? So the idea is that we are joining effort with SIGRA, and SIGRA Puerto Rico is also one of the NOAA programs that is responsible to work in the Local 2030, to work at the macro level, as I mentioned before, connecting different islands in the Caribbean region. So building that bridge that would help us to understand what other islands are doing. And let's use this as an example. What other islands are doing to work with water scarcity, what other islands are doing with coastal erosion, what other islands are doing with sea level rise, with water resource management. So we have so much to learn because we have so much similarities, but we also have so much differences. But the idea is that with that kind of network, we might be able to start bridging that collaboration at the regional level and not staying only in Puerto Rico and Virgin Islands. That's a unique opportunity that we are exploring. To be honest, we still don't know where we're going to be ending with that initiative, but it's promising, and we're very happy to be part of it. Can we go to the next slide, please?
Yeah, and I think we should put it in the next minute or so if that will work for you, Pablo.
Sorry, I don't hear you.
Oh, can you hear me, Pablo?
Yeah, I can hear you.
Oh, yeah, we want to wrap up in the next minute or so.
Okay.
If that will work for you.
Yeah, perfect. I explained it already. If you want to have more information about the Local 2030, you just can go here. Can we go to the next slide, please? So this is thank you, Elisa, for doing that. So it's going to be easier if you share the link in the chat so we can continue to the other slide, please. So we are going to be holding, based on the first year on dialogues and conversation, as I mentioned, we are already joining efforts on the kind of issues that the community identified in Puerto Rico. One of them was extreme heat. So we are designing an extreme heat summit with the Department of Health, with the Emergency Management Agency, with multiple others organizations, with the Ecoexploratorio Science Museum, Department of Education, and as you can see, multiple other academic and state agencies that are aiming to work on extreme heat in Puerto Rico. We're also going to be working on capacity building activities and training for most of the staff and executive staff in the different agencies in Puerto Rico that are responsible to work on preparedness and response for extreme events. And we're doing a capacity building activity in January in coordination with the Emergency Management Agency locally in Puerto Rico. Can we go to the next slide? And I think we're almost here. A couple of examples that you will not be seeing during the afternoon and the rest of the day today, but I don't want to leave them behind. We do have also the capacity of one of our researchers and scientists working with us that is developing early warning system for landslide. Is mainly emphasizing in Puerto Rico. We will try also working together to see to what extent we can work also with these kind of tools in other places in Virgin Islands. Can we go to the next slide? This is the other that we have also. We have the collaboration of Institute for Man in Remote Sensing at the University of South Florida with Frank Mueller-Carter, that they do have also a lot of techniques and tools available and collecting information on ecosystem, marine ecosystem and coastal ecosystem, mainly for Puerto Rico and Virgin Islands and the whole Caribbean region. Can we go to the next slide? This is a part of the group in terms of the in the planning meeting that we did early this year, 2023. You can see me there, and you can see my son. He actually was with us during the whole meeting. I think that there is only one slide for barriers and challenges, and that's it, we finish. So that's it. In terms of what we have identified up until now during the first years, so in terms of barriers and challenges, talking in general, I'm not talking about any specific community or agency. So there is a race against time to spend the recovery funds that we're seeing here. There is a lot of money available right now in terms of recovery, but most of the money that is being allocated doesn't have a plan, doesn't have ideas. So it's very difficult to receive hundreds of millions or billions of dollars without a plan and to know how to use the kind of and spend that kind of money. So that is related to the complex disaster recovery governance that we have and the social, economic, and political factors that make us more vulnerable, and also the community. There is a lack of technical scientific knowledge in most of the cases. That's why the reason why we're doing this capacity and trainings with the agencies in Puerto Rico. But also we can transfer that as opportunities. So there is a lot of opportunity to do capacity buildings and trainings if they're target and if they are specific, because the communities are asking for this kind of information. Community planning activities, as you will see also from the colleagues from the WPI as well, equitable financing solutions. So how do we use these recovery funds, and how do we start thinking on to use it not only to build back, as always they are mentioning, but also something different, equitable with the communities and working with JEDI, right? And the self-organization has sense, and also the community trust and the community-based organization. And with that, I think that I finished. Thank you so much for being here, and I will leave it to the rest of the team to speak also on what they are doing with their amazing work in Puerto Rico. Thank you.
Thank you so much, Pablo. What an incredible amount you've accomplished in just such a short amount of time. And we're so excited to hear from our next group of speakers, Dr. Mimi Scheller, Dr. Sarah Molinari, and Dr. Sarah Strauss.
Thank you. So we're very happy to join you all here in the Climate Service Providers Academy to talk about the way in which the NOAA Climate Adaptation Program supporting the Caribbean Climate Adaptation Network has really emphasized multidisciplinary teams and different kinds of cross-cutting research, and really putting at the heart of it people, communities, equity, inclusion, and transformation. So we're going to get into the heart of that part of this project that's about human-centered design, and in particular, using project-based learning methods for improving community climate adaptation. And I will be joined by my other colleagues from Worcester Polytechnic Institute, Dr. Sarah Molinari, who's our postdoctoral fellow on the CCAN Climate Adaptation Network, and Dr. Sarah Strauss, who's a professor of anthropology and climate adaptation here at WPI. Next slide, please. So our key objectives that we want to cover in this brief presentation is how we are leveraging the synergies between teaching, research, and community action and linking it to the objectives of community climate adaptation. WPI as an institution specializes in project-based learning. We've been doing it for more than 50 years, including for 30 years at our San Juan Project Center in Puerto Rico. And we want to show you today how we use project-based learning and human-centered design with communities to help improve climate adaptation and resilience actions, planning, and decision-making. And as you probably know, after Hurricanes Irma and Maria, Puerto Ricans may have felt that the government agencies, whether federal or state level, territory level, didn't do as much as they could have, and that many communities were kind of left on their own. And so they forged ahead and had to create their own resilience and their own adaptation strategies. So we're trying to learn from people, from communities, about what they've been doing since 2017, what they've learned from that, what they're doing now, and what they're doing into the future, and also how we can support that and how we can help link those community-based actions with the possible funding opportunities that are coming, especially from the federal government. So we're going to show examples of how our undergraduate student research teams can be integrated with climate adaptation research objectives, and how they can help us improve community participation and human-centered design. And then secondly, Dr. Strauss will talk about our master's degree in community climate adaptation, where we also have graduate students doing fieldwork in Puerto Rico and in the US Virgin Islands to help build that cross-regional knowledge sharing, action, and comparisons. Next slide, please. And this is just a very brief overview of how our global school at Worcester Polytechnic Institute is a hub for interdisciplinary, immersive, experiential learning through team-based projects. We have 50 project centers in 34 countries. 100% of students receive a scholarship to support their travel, and they travel in groups of 24 students, usually in teams of 4, with 2 faculty advisors traveling with them. And so our teams in Puerto Rico, we have groups of students there from January to February, 24 students, and then another group of 24 students from March to April, all working on community-based projects. Next slide, please. So the challenge of climate adaptation, and this is really our kind of key argument of our presentation, is that the complexity of climate adaptation, the hazards and risks and vulnerabilities as they all come together, require participatory human-centered design and action. And at the heart of that has to be people. We draw on community-engaged action research strategies to understand what the local concerns are, what the needs are, and what the initiatives are in particular communities with specific stakeholders. This is what we call co-creation, and it's a participatory design framework. The community sponsors who we work with define their own problems. They co-design the approach with us, and they determine the results that they want to see. So when we speak of climate data and information for the community, for the Caribbean region, as social scientists, we ask, who is that data for? Who creates it? Who owns it? How is it put to use? How can communities use and act on that data and information? Secondly, we look at specific places, drawing on multiple social science methodologies that bridge technology and society. And that includes how we can help with local downscaling of these various tools that are identifying climate risks and impacts, but make them usable knowledge grounded in specific places. And thirdly, we look at the planetary level, looking at the environmental studies, the science studies of complex hydrological or heat systems, or as we saw, landslides, coastal flooding, any of those kinds of mapping strategies and data collection strategies to talk about how we can turn those into potential mitigation strategies by working with these community partners. So next slide, please. We're now going to hand over to Dr. Molinari, who's going to speak about examples of our undergraduate projects with communities. Thank you.
Thank you, Dr. Scheller, and thank you for everyone for being here and to the CCAN network. I'm really lucky in my capacity as postdoctoral researcher for CCAN to be working on these interactive qualifying projects with the students and also during their preparation terms, which are happening now. So as Dr. Scheller was explaining, these projects are meant to integrate science, technology, and society, and importantly, to forge lasting collaborations with our partners in Puerto Rico around issues such as sustainable development, climate resilience and adaptation, and environmental management. So I'm just going to briefly highlight some of the projects that the student research teams worked on for the terms in 2023, between January and May 2023. And at the end, I'll talk briefly about some of the upcoming projects we have. So this slide is about a participatory mapping project that students worked on in a community called La Perla. And La Perla is an urban coastal community in Old San Juan that has for years been the target of both disinvestment and real estate speculation. So this project team worked to collect data to create assets such as art and murals, and also to work with community leaders on evacuation routes for emergencies. And what the students did at the end was that they hosted training workshops to teach residents and community leaders how to use the mapping software tools that they created. Again, going back to this question about climate data and info, how it's put to use, it's important that the student teams are imparting the knowledge that they're co-creating with the projects. Next slide, please. Another project that the students worked on earlier this year was based in the mountainous region of Canóvanas in a community called Cubuy Lomas. And this project focused on a rescued or repurposed school in the mountainous region. And the organization that runs this school is called Ixalaya. And they've created a community center in the repurposed school. And their work focuses on emergency preparation, agroecology, and also local health issues. And so the students on this project created place-based resilience assessments to address the community-defined issues through a research process that they grounded with interviews with residents themselves. And this project resulted in strategic partnerships that supported pathways towards sustainability and infrastructural innovation for Ixalaya and the repurposed school. Next slide, please. Another 2023 project was really a case study on two resilience centers in Puerto Rico, one in a rural area and one in an urban area. Of course, these are areas that face different kinds of climate hazards. And the objective of the case study was to assess how these resilience centers were developing and what are the kinds of challenges that they're facing around community climate adaptation. And the students' project and the case study informed the creation of an emergency management toolkit, a mapping system, and outreach campaigns to advance local emergency response. And this, I'll just say also, this emergency management toolkit is something that we're continuing to use with the 2024 projects. We're adapting for the new projects and places that the students are working in. Next slide, please. This slide has a number of pictures from the rescued school project, Ixalaya and Cubuy Lomas, and you can see the student teams in action. It's a very hands-on process, as you can see. Next slide, please. And finally, our upcoming projects for 2024, the January through March term and then March through May terms, we have 3 projects that are centered around designing community resilience hubs. And one of these projects is based on a new partnership we're developing with a mutual aid center that's also in a rescued school in Caguas, Puerto Rico, in the central region of Puerto Rico. And there we're supporting community leaders to develop an emergency response plan. This is an organization that emerged after Hurricane Maria as a kind of social hub for emergency response and a community kitchen. So the students will be collecting data based on a small pilot survey of elderly residents that the Mutual Aid Center delivers lunch to. So they're going to be working along the lunch route to assess the needs for the emergency response plan. And another upcoming project we have for 2024 is a partnership that's been ongoing for a number of years now with an organization called Para la Naturaleza, which is a land conservation organization in Puerto Rico. And students will be working to develop climate adaptation strategies in the southern coastal protected area called Punta Cabullones. And the team will be documenting relevant environmental management information around biodiversity, restoration needs, and zoning. So we're really looking forward to these 2024 projects. And I'll pass it to my colleague, Dr. Sarah Strauss.
Thank you, Sarah, and the SAP folks, all of you for coming and joining us today. So I would like to talk first about our graduate program, a little bit about our signature undergraduate program that focuses on our project-based learning skills and teamwork, bringing interdisciplinary teams of undergraduates around the world. We build on that infrastructure with a new graduate program that's just only recently graduated its first graduate, and we are building this program now. It's an 18-month program that is joint between our Department of Integrative and Global Studies and also our Department of Civil, Environmental, and Architectural Engineering at WPI. And so it's a master's program with a full semester of fieldwork. And so our current focus for comparative climate adaptation in different communities is with the Caribbean through our various NOAA grants, and then also in the city of Worcester, Massachusetts. So here you see Solange Uwera, one of our graduate students from Rwanda, and she was in Puerto Rico last year with the launch of CCAN, and so she spent January to May with communities in Puerto Rico, looking specifically at the ways that community-based organizations, primarily, and other kinds of NGOs develop particular community engagement strategies to work with local communities. And so that is our first project. Next slide, please. And I will say we have another student who is working, kind of bridging the gap, as a PhD student, Varun Bhatt, and he is working in a comparative framework with San Juan, with Worcester, and with Mysuru in India to develop a platform for supporting green jobs for climate adaptation in very different kinds of locations. So that takes the example and again supports our comparative framework. And then finally, we also have a supplementary grant that's just coming online now that is from NOAA, the BIL grant that is to support the CCAN project with, in this case, bringing us to share best practices with a longer standing RISA CAP program, the CCRUN from Drexel, and then working specifically with our other colleagues at the University of Virgin Islands that are also part of the CAP. And so we have a team that will be of 2 graduate students, sort of mirroring the undergraduate focus on teamwork. And they will be in Virgin Islands from January to May this year. And then there will be 2 subsequent teams in 25 and 26 also working on, in this case, the first team will be looking really at what Mimi talked about at the beginning, the range of different stakeholder perceptions and concerns related to climate risks and adaptive strategies, and trying to understand from within very different local communities on these islands how they are perceiving these risks and what things they see as critical to their own success, and then how government agencies and NGOs are looking towards interventions and trying to make sure that the implementation gap between what is being proposed to do and what communities see as needs is a little bit more engaged through those kinds of approaches. And so, yeah, next slide. I think we're done with this at this point, and to just simply say thank you all, and we'll open it for, I don't know, 1 or 2 questions if we have time.
Nope, not going to break yet. Yes, thank you so much, Sarah, Mimi, and Pablo. What a wealth of information. What really exciting ways of integrating data and information from many disciplines, and most importantly, lived experiences and community-based information. So thank you so much for sharing. We are going to take a few questions before we go to break. And so I want to remind folks, we only have a couple questions in the chat so far. So just want to remind folks that you can put questions directly in the chat. All right, so this first question is, and I do want to make sure that Pablo is still here, because I know he is juggling us with the National NOAA CAPRISA meeting. Okay, thank you so much, Pablo. So this first question is for you. What has been the participation or collaboration of CCAN in the Mitigation, Adaptation, and Resilience Plan in Puerto Rico that's currently in public hearings, and what's your opinion on the plan you'd like to share?
Yeah, first of all, thank you for that question. It's been that the person who is asking is very well informed of what is happening in the case of Puerto Rico. So yes, I'm one of the 6 scientists that work. I answered in the chat that work in that plan. This is a draft that is being shared now to receive more comments and suggestions. It's far from being perfect. So it's as any other plan, right? So we're hoping to, with receiving this kind of information, to open that process of incorporating things that we miss, incorporating topics, incorporating issues that are real concerns also for different sectors that for multiple reasons that were unable to participate in the elaboration of this plan. And so I shared it with the team. And the idea, we haven't discussed this yet. To be honest, we have been very busy traveling or doing multiple things for all of us. So I think that at the last meeting, we needed to cancel it or postpone it. Let's say postpone it, right, maybe. But that will be a great opportunity, I think. I think that we have the resources, we have the strength and the capacity for some of us, beside me, because obviously I'm one of the authors, I cannot comment on it, but for some of the other scientists here working with us to read some section, a specific section, you don't need to read it all, but to comment and to make sure that CCAN is making official suggestions to the government of Puerto Rico in the different sectors that they are considering for climate adaptation in Puerto Rico. That is something that I love that idea. I don't want to give more work to the team, that I know that they are already working a lot, as you can see. But it's a unique opportunity, right? When we're talking about this is a unique tool that it might be approved by the Congress of Puerto Rico. So, yes.
Excellent. Thank you so much. And hopefully a model for other states and territories as well. All right, do you have time for another question or two? If other folks want to type in the chat, or feel free to raise your hands and you can share your question verbally.
And while we're waiting, I'll just say thanks to Roderick Scott, who posted the floodmitigationindustry.org website. And I just want to say, for those kinds of collaborations, for anyone out there who's actually doing climate services provision, we always are looking for sponsors of these kinds of projects where we can get tools or different kinds of processes that you might be working on into the hands of student teams working directly with communities to test them, to pilot them, to get feedback on them. And and really sort of make that connection between a lot of the service provision that might be happening in the continental US might not be getting to the island communities, for example, and maybe they have different needs and different ways of using those tools. So we're always happy to test those.
Awesome. And we are all about collaboration here at the Academy. So that's perfect. And I think, Hannah, did I see you maybe putting your hand up on the video?
Yes, thanks, Rachel. Well, first of all, I just want to say how unbelievably inspiring all of these presentations have been. It's really exciting to see this kind of integration, the real focus on equity and respect for all the partners at all levels of education and backgrounds and community members is just a stunning model. So I just want to appreciate that and say really, I think everybody else has a lot to learn. And I'd like to hear about, what kinds of equity strategies are you using that you really found successful that we might apply in other parts of the country? Thank you.
So I'm not sure if Pablo, if you wanted to come in on that
I will
answer.
go after you. Yeah, go ahead.
Yeah, well, I mean, just first of all, of course, the NOAA CAP programs importantly bring in local institutions, right, and local sponsors, local leads of the research and the students who are from the region. So number one, just at the sort of researcher level, the student training level, it's a really important fact that we're training researchers and students in Puerto Rico and in the Virgin Islands, number one. But in what that does is it also helps us have the presence there to be in touch with our partners and for equitable relationships. That continuity is really important. And Pablo, I'll hand over to you because you are the expert at building those linkages and keeping them going.
No. Thank you, Mimi. So yeah, first of all, the University of Puerto Rico is a minority serving institution, right? Which is serving, as Mimi was mentioning, to 98% of the students here are Hispanic, or Latinos. So we're working directly with the underrepresented workforce and STEM, in sociology, and different components inside of the United States nationwide, where we're thinking like that. But also considering that we have the Virgin Islands. So in the case of Virgin Islands, it's something similar. So we have two different minority serving institutions that are working hands on hand with capacities and developing students. Also improving this kind of research that is working with as underserved and underrepresented communities. If you notice, we are not using only the word of frontline, because as I mentioned before, this is something that we have been discussing not only in this group, but also in the NCA 5, that frontline communities might be masking or whining the underlying process of why most of the communities on work we are working are vulnerable to climate change, right? And those vulnerability factors are not necessarily related to the climate stressors. So we are paying attention that we are what we're working, we are addressing social factors and that might help these communities to overcome those inequalities that they're facing. I don't know if I answered your question.
Thanks so much, Mimi and Pablo, and as well as Sarah. And Sarah, okay, so if you are still on your break, hopefully you will find your way back to the computer soon. We are really excited to be welcoming Eric Harmsen and Patricia Chardin-Maldonado. So Eric is a professor at the University of Puerto Rico Mayaguez campus in the Department of Agricultural and Biosystems Engineering. He teaches courses in agricultural hydrology, agroclimatology, and irrigation. And his research includes measuring and modeling all components of the hydrologic cycle, remote sensing of water and energy balance in the tropics, and agroclimatology. And Dr. Patricia Chardin-Maldonado is a coastal and civil engineer with experience in coastal morphodynamics, ocean and weather modeling, and designing coastal hazard mitigation alternatives. She earned a BS in civil engineering, an MS in environmental and water resource engineering from University of Puerto Rico at Mayagüez, and a PhD in coastal engineering from University of Delaware. And she serves as the deputy and technical director of the Caribbean Coastal Ocean Observing System. And co-leads the design and implementation of observation and numerical modeling components there. Okay, so welcome, Eric.
Thank you. So yeah, I'd like to share with you just an example of one of the tools that we're developing and working with on the project. There are a number of people who are developing tools for different types of extreme response to extreme weather. And so this is just an example. This is going to be a pretty big shift from the earlier presentations, because I don't know what the ratio is, but we have a lot of social scientists on this project. And then we have, I'm going to just guess that maybe we have half and half social scientists versus Earth-related scientists. And so in this talk, I'm gonna refer to a computer model which we've been developing over almost the last 15 years. And it's a water and energy balance model. Let me see if I can, if you could advance the slide here. And it's called GOES PR Web, and GOES stands for the GOES satellite, which is the Geo Observational Environmental Satellite. PR is for Water and Energy Balance Model. And the thing that's kind of useful about this model is that it requires a lot of weather data as input, rainfall, solar radiation, temperature, humidity, etc. And all that data is in a gridded form, 1 kilometer resolution across Puerto Rico. And it's available to the public. And from that, we then develop data sets of runoff, aquifer recharge, soil moisture, and various other, as you can see here, there's more or less 25 hydroclimate variables available. Next slide. So this is just an example of some maps that the model produces. It's a random day in 2015. And as you can see, there's rainfall, aquifer recharge, runoff, soil moisture, actual evapotranspiration, net radiation. And then there's some energy flux components, latent heat flux, sensible heat flux. So some of these things the public might find of value, but some are a little bit more useful to the scientific community. Next slide. So I'm going to show a few applications. The drought of 2015, the south coast of Puerto Rico aquifer recharge evaluation, looking at climate change and future predictions of recharge, aquifer recharge. And finally, a crop water use and irrigation scheduling application. Next slide. So this is the rainfall for, I think it's, let's see, it's 8 months during 2015. We had a tremendous drought that year. And as you can see in the lower left, this is the NOAA drought monitor for Puerto Rico. And 2015 is at the location of that very orange result. Orange represents, I believe, it's moderate drought, and then you have the lighter brown is abnormally dry. Oh no, I think it's severe drought is the orange one. But anyhow, what you can see here is an evolution of the rainfall across the island. And in the blue, probably a poor choice of color here, but the blue represents dry or no rain. And what the eastern side of the island was severely impacted for about 5 months. And the arrow at the top on the left shows El Yunque tropical rainforest. And you can see month after month, the rainforest wasn't receiving rainfall. And one of the fears is that the predictions for the Caribbean, this part of the Caribbean region, is that it'll get drier in the future. And so there's a real threat to this tropical rainforest, that the ecosystem may be transformed into another type of environment. Next slide. So this is just to show, here we have the moisture content, which is useful for information for farmers, for understanding, exactly how dry things are getting, how much the dryness of the soil impacts the ability of the watersheds to produce runoff, which then fill the reservoirs. If the soil is really dry, the soil profile, and we were receiving very little rain, we're not going to fill up the reservoirs, which we have a network of them all around the island. Next slide. And this is what's called the rainfall deficit. So it's defined as the rainfall minus the evapotranspiration. Really, it's the crop water requirement. So if you have more rain than you do crop water requirement, you get this white area, which means there's an excess of water. But in all the areas where we have color, we have deficits. And these are large deficits. The reds represent 140 millimeters of rainfall deficit during a month. So you can see some areas where it's red month after month after month, developing, many hundreds of millimeters of deficit. Next slide. And then this is a crop water stress coefficient. It indicates when a crop will start to experience stress, and for agricultural crops that represents a reduction in their yield. And so in the areas that are darkish brown, you have a value of 1, which means there is no stress. But you can see in the eastern side of the island that at least during May, June, July, and August, there's the bluer area, which indicates stress, and it may represent a condition where the soil moisture hits the wilting point, which means that there's simply no available water for the plants. So the Puerto Rico Drought Committee is a committee which followed the drought during that drought and continued up until today. In fact, I had to excuse myself from the Drought Committee meeting, which was the Puerto Rico Drought Committee meeting was today. So what they do is they use this information along with other information such as the weather outlook, stream flow, groundwater levels, water reservoir levels, agricultural conditions, forest and agricultural fires, and other things. And they come up with an assessment of how bad things are in the island. And so this model provides just a little bit of addition to that whole mix that the drought committee uses. Next slide. So in the southern coast, there's an aquifer, which is very, very important. There are a lot of farms in that area, but it's very, you could say it's semi-arid to arid in that area. So if you don't use irrigation, you can't really farm in that area. Nonetheless, the rainfall that they do get is critically important because it recharges the aquifer. And the farmers use more than half of the irrigation water they use comes from the groundwater system. So if there's a reduction in the aquifer recharge, there is going to be less water available, not only for irrigation, but for water supply. And we know with rising sea levels and then dropping water levels, we may have contamination from saltwater intrusion. So what we did was use 2 global circulation models to predict the future weather conditions, and then use Ghost PR Web to estimate some various parameters, including the aquifer recharge and the evapotranspiration, which is the water that's being used by the plants. Next slide. So what this shows is what basically I'm cutting right to the results. The change in rainfall, the CNRM is a global circulation model which simulates the weather globally. And the CESM is another model. And the average between those two for rainfall, you can see, was roughly a drop of 15% in the rainfall in that area. The aquifer recharge, though, dropped by 40%. And then finally, the last row shows the change in crop water use or evapotranspiration that is about 6%. I'm sorry, it's not a drop, it's an increase of about 6%. So when you have less rain, you have less aquifer recharge, and then there's a greater water demand by the crop because of the warming conditions. And the bottom line is that we need to manage that aquifer very, very carefully. Otherwise, we may lose it to saltwater intrusion in the future. So at the bottom here, it says, as part of the CCAM project, we'll perform a similar analysis for the U.S. Virgin Islands. So next slide, please. We have been evaluating crop water use or crop water requirements for the U.S. Virgin Islands and Puerto Rico for about 15 years now. But we're in the process of developing the full water and energy budget models for each of the Virgin Islands. So if we could move to the next slide. Next slide. So here's some preliminary results that we've come up with in the last, I guess, since about January. Since about January, we've been working on this. And this is a random day during June of 2023. You can see in the top left, we have some rainfall. This is for the island of St. Croix. It shows surface runoff, actual evapotranspiration, and volumetric soil moisture content. And of course, there's another like 21 hydroclimate variables that are produced. We're currently working on St. Thomas, and we'll then work on St. John. So this will provide some needed data sets that at a 1 kilometer resolution for the U.S. Virgin Islands. Next slide. We're also working on a tool on the online for plotting the data at any location. Usually people, when they see a map, they're not interested in the whole island. They're interested in their location. So next slide, please. So with this tool, you can select a location, a date range, and up to, I think it's 5 parameters, and you can get plots of the information, and it's quite user friendly. So we're working on that at the moment now too. Next slide. So this model that we've developed for Puerto Rico is being used by the National Weather Service, by the Puerto Rico Scientific Drought Committee, the U.S. Forest Service, the U.S. Geological Survey uses it for water use reports. And there are some people who are developing various types of models that use the data as input. For example, there's a group using CWAT, which is a groundwater flow model, and they're using evapotranspiration from our model. And then another example is Geisha. It's a flood model, flood simulation model that was used during Hurricane Maria and Hurricane Fiona, and they use soil moisture as for the initial conditions in the model. Next slide. So how does this relate to adaptation efforts? So we hope to be developing drought indices and prediction. Since the model includes all kinds of weather information, we'll be including heat indices, irrigation scheduling, and other agricultural tools. I personally have an interest in developing rooftop water capture for the 4 islands. And it does provide solar energy information, and over the years people have used that for designing solar energy systems. It can provide information that will help determine landslide potential via the soil moisture information, and fire potential, and in general information about water resources management. Next slide. So what are the challenges? How do we make tools like GhostPR Web more practical for regular people? I'm hoping that over the life of this project that we'll be able to work with our social science component partners and figure out ways to make this more useful to people. Other challenges include validating the results for the USVI. There's been quite a bit of validation done for Puerto Rico, but the USVI models are brand new, so they'll need to be validated. One issue is, how do you perpetuate these operational models? They run every day, and they run into problems. Sometimes data from the satellite doesn't come in, or and I personally have to sort of maintain it. So these models don't exactly run by themselves, and so how do we perpetuate these operational models that can be very valuable for the community? And then one thing we're doing now is we're building models for St. Croix, St. Thomas, St. John, and we're looking at the possibility of developing a full Caribbean-wide model, single model, and so that's a possibility for the future that we're looking at. And that's all I have.
Thank you so much, Eric.
You're welcome.
Yes, really getting into the hard data here, and we're excited to now be joined by Patricia Chardin Maldonado to lead us home with our final presentation. Thanks, Patricia.
Hi, thank you. Do you hear me well?
Yep.
Perfect. So thank you again for the invitation. In the next few minutes, I'll be talking about the Caribbean Coastal Ocean Observing System, better known as CARICOS. I'm going to highlight the work of many students and scientists that have been part of this project. And I would highlight some of products that we have in our web portal that are used for decision making and the interaction that we have with the community user and stakeholder to develop such products. So next slide. As a background, CARICOS is one of the 11 ocean observing systems that comprises the US NOAA IUS enterprise, or the Integrated Ocean Observing System enterprise. And we respond to stakeholders, users, and community requests for essential coastal weather and ocean data and information for the US Caribbean archipelago, which includes Puerto Rico and the US Virgin Islands. So before CARICOS, before 2008, I'm showing here a map of the different instrumentation that were installed in Puerto Rico and the US Virgin Islands. Most of them were weather station and tide gauges. So we didn't have any ocean data buoys, no real-time data of wave and current, very limited coastal weather stations. And because of that, we didn't have information to use as initial and boundary condition for high-resolution numerical models. But we know we have a lot of regional challenges and many stakeholders and users. And just showing you on the bottom of this slide, several of them. We have some of the regional challenges that we always highlight is the extreme wave events, the tropical cyclone activities, and of course the traffic, the navigational traffic that we have around our region. So thinking about those regional challenges and talking with the stakeholders, learning about the needs and how they wanted us to present the data for the day-to-day operation. The many individuals that were part of CARICOS start developing and evolve the system that we currently have. Next slide. In a more of icon way, and what the CARICOS existing capital capabilities, we have right now 7 ocean and wave data buoys that covers all coastlines of Puerto Rico and the US Virgin Islands. We have 18 weather stations. We have 8 Asia radar system, and we deploy during the hurricane season what is called the underwater gliders. Next slide. This instrumentation provides different parameters, different information that is presented in real time, most of them every 10 minutes to an hour. The oceanographic data buoys provides information about wave height, wave direction, and wave period, the wind speed, the wind direction, the barometric pressure, air temperature, current speed and direction. We have water temperature and salinity. We have other wave buoys that only give us wave data, wave height, period, and direction. The high frequency radar or Asia radar give us ocean current speed and direction from close to shore to approximately 700 kilometers offshore. The weather stations provide us wind speed, wind gusts, wind direction, temperature, atmospheric pressure, humidity, and precipitation. We also have an ocean acidification monitoring buoy located on the southwest coast of Puerto Rico, and it measures the atmospheric carbon dioxide, the seawater carbon dioxide and pH. And as I mentioned, on the water gliders that provides us with temperature and salinity information from the ocean surface up to 1,000 meters deep. So all this information is presented for different users and stakeholders. Buoys, most of them are used for marine operation and beachgoers to decide when they want to go out, if it's safe or not. The Asia radar is mostly used for the US Coast Guard and the search and rescue operations, also for the emergency responders initiative or efforts. The weather station is one of the information used for the National Weather Service San Juan office. The ocean acidification is now one of the most popular one because it's the only one that we have on the side of the Caribbean. And it provides us information, at least some information about how the climate change, the climate variability, the heat waves are affecting our coastal ecosystems. And this specific buoy gathers as information, this biochemical information, important to learn about this and to support the initiative of different NGOs and local agencies doing efforts in coral reef restoration, among others. And the underwater glider data is used to send it to the new National Hurricane Center to improve the tropical cyclone intensity forecast, especially for us for preparedness. So it keeps improving these models and then provide us information ahead of time, and we can prepare in time and avoid any type of heavy damage. Next slide. So what we do with this information, as I mentioned before 2019, we didn't have any data that could be used in high resolution numerical models, which are important because we have specific peculiar coastal processes and ocean conditions. So with the data that have been collected since 2008, we developed different data products to provide the user and stakeholder with the information for the day-to-day operation. So in Caricus, we run in-house high-resolution forecast model. We have the wind model, which is higher resolution is 1 kilometer. We have the wave model that goes from 100 meters to close to 10 meters close to shore. We also have an ocean circulation model that I'm not presenting here, but it also captures what is happening on the surface, but also have different layers and can reach to the bottom of the different locations around our region. So with this information, we can support the different warnings and information provided by the National Weather Service to our citizens, and they use this information to share with others the conditions that will affect our coastline. And here's some example of the data in a social media post. Next slide. If you keep evolving and expanding those tools, those numerical modeling tools, we have been able to do specific products for beachgoers. So when you interact with the user, sometimes they need information in different ways. There are people that like figures, there are people that like digits, others just like something that reach their attention and they can decide really quickly. So we develop what you can see on the satellite images is a product of breaker high forecast. So with the different flags and the colors, if it goes from green, which is low, the height of this breaker will be low, and the conditions when it's red, then it will be a little bit challenging for the people, so they need to take in consideration and decide beforehand if they want to go and visit that location. And then with that, we also develop some signs that are put in different locations to explain them about the dangerous currents. Unfortunately, we have a lot of accidents here with drownings, so they want to provide that information. This is a product developed Caricus with SIGGRAN and the National Weather Service in one office. And we provide this tool in our webpage, but we also provide the data to the National Weather Service, where they have developed an additional product with that information. Next slide. Something that we start supporting, as I mentioned before, we have the ocean acidification buoy. But because of new issues that we have around the island, known as the sargassum, that impact that has in our marine life, in public health, and also in our ecosystem. We start developing this short-term forecast about sargassum arrival inundation forecasting tool using satellite images, our ocean circulation modeling, and the Asia radar data. And we can provide you with a 3-day forecast on how the sargassum will move in our region. We have some issues years before where the desalinization plant in St. Croix got affected by this seaweed, affecting then the drinking water of the region. And then in Puerto Rico, power plants in the south coast of Puerto Rico also have an issue that got plugged. The intake got plugged with sargassum, and then there was a 2-day power outage in Puerto Rico. So with this tool, we want to provide these agencies the information ahead of time, and then they will have time to prepare and to take action before anything could happen, and then any type of citizen can be protected. Next slide. This is just some of the examples. This is the different newspapers and the information that was put out. And I wanted to show you this image that we took with a drone of the significant amount of sargassum that reach the coast. And when this gets degraded, then it's another issue and goes directly to public health. So it's something that we want to think about and use the pro that I presented to prepare ahead of time and avoid any type of issue. Next slide. This is the first, the images on the top is the ocean acidification buoy. I just want to present the figure here so you can see one of the parameters that are measured. So the red line is the data measured here, Puerto Rico, south, west coast of Puerto Rico. And then the black line is measurements in Hawaii. The parameter is the atmospheric dioxide, the carbon dioxide. And you can see that it goes positive. Since 2008, we started measuring Puerto Rico. I know the time series is longer in Hawaii, but you can see that in different oceans, we have the same signal. So it's something that we know. We have to think about how this ocean is absorbing and how this will affect our marine and coastal ecosystems and marine life. So thinking about all these changes and knowing that climate change keeps now steady, and unfortunately we are seeing the effects of it, we start developing different products to provide the user or any agency NGO that needs the data about the biochemical parameters in the water that could help them decide where to do the efforts, how it's affecting their initiative, or how our ecosystem are changing. So what we did is satellite-based virtual buoys, satellite-based data, virtual buoys that we located. Right now we have 20 of them. We located around the region, and it provides different information: turbidity, light penetration, chlorophyll, sea surface temperature. And I think we have from 2004 sea surface temperature and other parameters from 2008. And then you can see how it's changing the months that we can see significant effects or damage to our ecosystem, where is worse than the other, depending on the initiatives that you're working. Next slide. If you click also in those virtual buoys, we want to expand the product and then include the information, not only from satellite, but with initiative from the Department of Natural Resources and the Department of Planning and Natural from the Virgin Islands. And include that information there. And then you click and you have a figure where you compare the parameters of the coverage, the different, the blank noise, the stone, coral cover, how different parameters you can compare with sea surface temperature. And then you can see and assess the health status and trend and threats of this coastal barrier ecosystem. Everything is more a product provided in different ways and depends on the user and stakeholders or the community itself, how they wanted to learn or how they wanted to present. If they needed another way, if they prefer another way, we also interact with them and go back and forth trying to adjust, because the important part is to provide that data to them for their benefit, for the initiative, or at least for the knowledge. So for that, we, because we know that we need more data and it's not easy to do so, and maintaining this 24/7 provision and providing the information to the citizens in this region, we are supporting local agencies and NGOs, providing them with instrumentation. And here on the bottom of this slide, there are two of them, which is the Seaverse, Seafox, and the YSI XO2. We provide that instrumentation to the different groups that are doing initiative in the coastal ecosystem restoration and protection in our region. They collect the data. We provide them the support to analyze, process, and publish that information, not only for them, but also for the public. So we are doing this right now with the Sociedad Ambiente Marino, el Estuario de San Juan, y Valleos. Next slide. So thinking about the user that wants to visit one local beach and enjoy a day, but we know that we have other concerns, not only the sargassum, but there are other sources that can affect the quality of the water at that location. We developed what is called Caricu's Beach Water Quality, or Caricu's Pathogen Monitoring Pathogen. And it's a tool that provides you, again, the icons, same as the flags that I showed you before, with different colors. And in this case, faces, happy faces, sad faces, and you can decide if it has the conditions. It provides you Enterococcus EPA levels. If they're above those levels, you will find like a sad face on the location that you want to visit. If it's lower, then it will show you or an intermediate or a happy face. If you go to this tool in the website and you click on it, you will see all the different, all the measurements that have been collected at that location. And then you can see the trend, and you can see if that location has a lot of events that go above the Enterococcus EPA level or below them, and then you can protect yourself or especially your children. Next slide. So this is, I wanted to highlight this product. I've been focusing on the water and the coastal ocean part of our region, but then we start in collaboration with Dr. Pablo Mendez-Lázaro and his team, this NASA supported project. Caricus is hosting this product. It was developed by a hard work of many scientists, but this tool tracks the seasonal aerosols, in particular the African dust, that travel across the Atlantic Ocean and express also their effect on air quality in the Caribbean. So this tool that you can access in our webpage, as soon as you enter, you will see the location of it. It will provide you the satellite images, the satellite-based estimate of this particle tracking tool. And then they have some gauges of 4 stations that measures these particles around Puerto Rico. And based on their analysis and in collaboration with different agencies of Puerto Rico, they were able to indicate a level of health issue to the people. So you will see different color, if it's low, high, and how it's going to affect. And then it also provide you the forecast of 20-hour and 48 hours. So it's a really nice tool, especially for for improving the health and well-being of our local citizens, and especially we have a lot of parameters working together at the same time, and they can affect the well-being of them. Next slide. One of the ones that I think they're really important are the underwater gliders. Here is a picture of them really close on our way to deploy it offshore in the water. This instrumentation simulates a dolphin, so it doesn't have propulsion. It just dives, and based on buoyancy, it just dives from the surface 2,000 meters depth, and it does that for approximately 6-7 months. So it stays in the water during the whole hurricane season, provides information on water temperature and salinity and other biochemical parameters that gather on the way to the 2,000 meter and up. It sends data approximately every 3 to 4 hours to the National Hurricane Center, where it gets implemented in the forecast model and gets improved, because these 2 parameters control how tropical cyclone, any activity in the water intensify. So with this information, we have been able to adjust and provide a better forecast, more reliable information to the local people, not only in Puerto Rico. This is an effort that continues in the US continental, but then improve and then give you more time to prepare. The bottom part of this slide, the figure in color that you can see, the blue and the red, is the anomaly. In this case, the temperature anomaly. And you can see that in the surface, there's a lot of changes, but in the bottom, it's a lot of red. So it's the temperature is warmer than before, than the climatology that we are using. Therefore, when the hurricane comes or a tropical cyclone comes and it starts mixing this layer and finding these warm waters, then it can get intensified. So that's why this information is really important. We're trying to deploy approximately 4 or more of these instrumentation in the water during the hurricane season. Next slide. So I present to you a lot of products that are accessible in our web portal. But how we can know it's easy to put this product out when you were not discussing this product with a specific stakeholder and user. But we know that information is important for everyone. So we started thinking how to communicate this and educate people and explain in an easy way, and they can learn and they can give us feedback, and then we go through back and forth discussion. So we thought about how, if the idea is not reach the community, let's reach the community through the students. And there's a way that the students and the young people gather the information. They know how to translate it in an easy way that the adult, the other part of the community can understand it. So Caricus, together with SIGGRAPH Puerto Rico, joint efforts with the Instituto Nueva Escuela, which is a Montessori schools in Puerto Rico, and the Puerto Rico Department of Education. And we started an initiative of designing coastal risk and informative resilient education centers. We call it CERCA, which means centers that educate about coastal and aquatic risk. What we are doing right now is developing a specific website of the location of the center. We provide information about weather, cyclones, wave, wind data, water quality, among other parameters, but we specifically show the location where we're at. And you zoom in, you can see your house, you can understand if the wave comes, it will impact my house. If a storm comes, the storm surge will impact my house, the tsunami, evacuation zones. So we developed this specific site, and the plan is to do this in 20 or more centers around the island. And then we have people, scientists from Caricus, professor at the University of Puerto Rico, and also the SICAN team will be able to participate and interact with the students and the community and provide them the information needed. And we think that with that initiative, the work will spread out. They will know where to look for the information, how to prepare, and then this, of course, we will be able to develop more, or at least adjust the product for to access more people and more communities. Next slide. This is just really quickly, if you want to learn a little bit more of what we have, what the data is presenting, how the system, the instrumentation, the different sensors, what they collect, where they are located, the different platforms. You can visit Caricus School. You will see some infographic. There are other tools, or videos, other information, as well as a contact if you need any webinar, any presentation, or if you need any more information. Please feel free to visit, and please feel free to express any idea or anything that you need. Next slide. And at the beginning, when I was presenting, I said that all of the products that we present in Caricus that were developed for our region were developed in the hard work of students. And I just want to highlight them and show a picture, a photo of all of them, and I'm missing some of them. No, unfortunately, we keep having students, but it's great to see that the hard work of young people is still there, is useful for many day-to-day operations, are important for us, for the community. Some indirect efforts that people don't know, but it's the hard work of these young people. Right now, most of them are doing PhD or working in different agencies, but we have been able to maintain and expand and improve those products as we have more data and we have more information to improve it for our users. So I just wanted to highlight that and say, that without them, we will not have that many products to present. Next slide. And of course, our collaborators that are always there to support us and to use the data and provide much feedback. I think that's the last one. Thank you again for the opportunity.
Thank you so much, Patricia. So we do have about 5 to 7 minutes left in our session that we can devote to Q&A with our speakers. And so we do still have Mimi and Sarah Strauss, Patricia as well as Eric here. So I do believe there was one question that came in for you while you were speaking, Patricia, and you spoke a little bit about this, about Kariku's tools that can support monitoring health of coral reefs. But if you want to expand on that a little bit, we did have that question come in from Carlo.
Yes, thank you for the question. We are doing different efforts, and we are collecting some information, some in situ information, water sampling. We have a chemical lab. This is part of the Department of Marine Science at the UPRM. We are supporting the NGOs that are doing this initiative right now, where there's a big fun opportunity that came out a couple months ago, and we have several NGOs, really awesome people that are doing this work of coral reef restoration. About modeling, no specific, we don't have an operational product, but we have scientists, part of Caricus, especially their research work. They're doing modeling about providing the information where to locate these new farms so they can get protected, or where we can relocate those farms when they're moved to the location that they wanted to dissipate the energy. As an example, dissipate the energy of wave when a big extreme event comes. And we know the modeling provides the information where will benefit more if we locate at different location based on the bathymetry, based on the shoreline orientation, among others. The health part of this coral reef is a new initiative. We're trying to develop a model that also includes the biochemical part. Right now, our models are physical, wave, wind, ocean, water temperature, tide. So we want to include this biochemical part. To do that, we are thinking about or working to deploy more sensors that can be installed on our buoys, together with the mooring system, and collect the different parameters that can help with them develop. But it's part of the initiative. It's something that is not a trivial, since we thought that physics was hard, but then when you go to this biochemical stuff, which has different scales, it's a challenge, but that's something that we're looking, and we hope to have it soon. But without the effort of collecting data, having the information, and the support of the other local agencies, this is not, and the NGOs and different individuals, the work will not be able to be done.
Thanks so much for those details, Patricia. And I know that we had a couple of comments that came in the chat about just how really impressive these tools are, and the applications that you've developed for them. So I do want to invite any folks who were listening in, if you want to come off mute and share a little bit about what you're thinking in terms of what you're excited about for these tools and any applications that you're thinking of. So if folks want to come off mute and share, please feel free.
I have a quick comment. This is Brian Smoliak. I just thought I want to express that, like, the human-centered design aspect of these tools is really exciting to me. It's really evident that you've tried to listen to your users and try to produce something that's valuable to them, rather than just, say, putting the data out there in kind of a generic format. That seems really tailored to use. So kudos.
Thanks, Brian. All right. Are there any other questions that are coming up for folks? Questions or comments? Really such a rich suite of presentations. And I feel like so much of the value today was getting to really dive into all of the different aspects of what CCAN is doing. And again, I am really blown away with, how young this collaboration is, and yet how much there is already happening on the ground. So it was super exciting to hear about that. And I know that Pablo had to run back to the NOAA CAPRISA meeting, but we're really grateful to have the rest of the team here, and really grateful for your presentations. Any last questions or comments?
Well, thanks, Rachel. This is Mimi. I just could add a comment. Thank you, for allowing us to present this work. And I'll just say, on behalf of Pablo, that we've gotten a lot done in this initial year of the CCAN network, but we're so excited about where it's going to go in the coming year and in the years after that, because there's just so much more impact we can have when we take tools like the ones that Eric and Patricia showed us, and then we really get them out, push them out into users' hands, get feedback, develop them, see how they're using them, and really develop programs, which then can be translated not just from Puerto Rico to the U.S. Virgin Islands, but working with the Local Islands 2030 network and the Caribbean community more broadly across other islands too. So, and to the Pacific, Risa. So we're just really excited about the potential here.
I love that. As adaptation professionals, we're always looking to the future, and I just love this call for us to continue following your work. Hopefully, to have you back at a future Climate Service Providers Academy. And yeah, thank you so much for that note.
Thanks.
All right. So we are reaching the end of our time for today. Make sure to connect with us on Slack if you haven't already. We also have, many opportunities for one-on-one consultations with all of our regional partners, as well as our staff here at NOAA, our staff here at ASAP. So feel free to sign up for one-on-one consultations. And then our next session is going to be this coming Tuesday. And that'll be our South Central session. So we're going to be joined by South Central Climate Adaptation Science Center, as well as the CAP-RISA team in the region, the Southern Climate Impacts Planning Program. So you don't want to miss it. We'll be back Tuesday at 1 p.m. Eastern. And please check us out and engage with one another on Slack in the meantime. Thank you so much, everyone. Have a great day.